Dear AS and or A-level students, hi again with mechanics. We are in dynamics part 4, the fourth part in the chapter of dynamics. We are today in resolving forces acting on a particle on inclined plane, moving on an inclined plane to the horizontal at an angle. In this lesson, we'll be writing the equations of motion for diagrams like this diagram. Like these diagrams, we must pay attention for something important first. It's one of the main ideas in this chapter. We must recall that, my dear students, that the weight is always making 90 degrees to the horizontal. Always. The weight makes 90 degrees to the horizon, to the horizontal. Fine? At the same time, the reaction force is always perpendicular or make 90 degrees to the surface of motion. In this case, in such diagrams, this is the surface of motion here. The particle will move up or down the plane, as we'll be seeing now. Up or down the plane. This is the language we'll be using in this diagram. So this is the first point I have to focus on with you. Weight is always perpendicular to the horizontal. Reaction is always making 90 degrees to the surface of motion, to the direction of motion. Okay, in this case, my dear students, since the weight is not in the direction of motion, look, since the weight is not in the direction of motion, so it must be resolved in two components, one adjacent, one opposite. To understand this easily, this is the particle moving on inclined plane at angle alpha. If this angle is alpha here, if this angle is alpha, so this angle is alpha. This and this are equal angles. Why? Quickly, we don't need to go deep with this, but it's good to understand for a few seconds. Since this is 90 degrees, so this and this add up to 90, so this is 90 minus alpha. We don't need this to resolve forces, but it helps to understand in other diagrams in general. So if this is 90, so this and this are 90. So if this alpha is, this is 90 minus alpha. Fact number 2, the whole angle here, don't forget this fact, is always 90. Between the cosine and the sine, the angle is always 90. So if this is 90 minus alpha, so this is also alpha. So this is the component that is adjacent to the angle. So it will be mg cosine alpha. Mg cosine alpha. And this one, the opposite one, will be mg sine alpha. This diagram, my dear students, has cases. Like we started this chapter in Dynamics 1 to the third part, we have cases. So you read these notes well. I wrote everything to you in details. We'll save talking and it will be a saved document to you to enable you to understand this more with written and hearing or listening. Okay, the first case we'll be writing the equations of motion for a particle if it's moving down the plane, and the plane is smooth. Plane is smooth. So this is the main force in this diagram. The language you'll be using, my dear students, in this diagram, which is very common in the M1 exams. This is the most common problems or questions in the exams for M1. So this inclined plane, we express this parallel to the plane, the forces acting in this direction or this direction, yes, parallel to the plane, and the forces like R and this component for the weight perpendicular to the plane. This is the language you'll be using in chapter 3, which is dynamics in M1 book for the Excel, or in general in dynamics and statics as well. When the particle is at rest, we'll be using the same language. This is parallel to the plane, this is perpendicular to the plane. In this case, my dear students, only one main force acting on the particle, so mg sine theta, there is no other forces. So this is the force, the only force in this diagram, equals to ma. Second equation, we got to get it from perpendicular to the plane. R is equal to mg cosine alpha. mg cosine alpha. Clear? Let's move to other different types of cases. The second case, or another case, the particle is pushed up or projected up a smooth plane by a force P newtons. So what are the equations of motion here? It's good to introduce these cases in this way. It will help us to be able to do any problem may come in the exam. We don't just start the problem without clarifying or resolving the directions of motion and the given information. We might be confused here. So this is the best case to start. We resolve the forces on the diagram like I did. Remember the weight is here, makes 90 degrees with the horizontal, with angle theta. This is the angle that the particle is moving on the plane, making an angle to the horizontal. This is called inclined plane. So the weight, which is here, is not affecting the motion. So we have to do two components. We said if this theta, so this is theta, so this is the adjacent, so this will be weight or mg cosine theta. I will write here mg because we used to write it. And this one, which is the opposite one. Good. If some of you don't see it well, I will sketch it here outside. Look, this is the plane. This is the weight. This one is theta. And this one, look, this is the right angle. So this weight, my dear students, look, the same idea. If you flip it like this, you will see it. Imagine it, the same horizontal plane. Yes? This is the weight or the mg. So this one is mg, this is the adjacent one, cosine theta. This one is mg sine theta. Do you see it? This is the easiest way, because some books do the complementary angles, they complicate this, to be honest. So this is the easiest way. Don't consider vertical and horizontal. You'll understand, you agree with me at the end of this lesson in a few minutes what do I mean. So in this case, we have force P up the plane. So it's the main force because the case told us or giving us the particle is pushed or projected up the plane. So P is the main force. What's opposing P? The component of the weight, mg sine theta, is equal to ma perpendicular to the plane. R in this case is equal to mg cosine theta. The next case, when the particle is projected up a rough plane, my dear, rough, we have friction now. by a force P. What's the new part here? Like we did in the previous part. But this is different direction of motion, different plane, different nature of motion. So the equations of motion, when you have P up the plane and the plane is rough. So you have friction now, as we learned before. So the main force is P newtons minus mg sine theta, which is the opposite component to the weight. And we have here mg cosine alpha. So we add them. Fr and mg sine alpha in the same direction. So we do add them, because both of them are opposing the main force, my dear students. So the equation of motion here, the force F here is what? It's the sum or difference between P and the sum of Fr and mg sine alpha equals ma. R is equal to mg cosine alpha. Remember this again, mg is here. You don't need to show this every time, but because we are introducing the cases for now, so to enable you and to remind you every time for now. And we have third equation, Fr, as we learned in the friction, in the lesson of friction before, equals mu r. This is the main diagrams for each case. The last case for today, before we start solving problems and give you work, and we'll do next after we finish dynamics and the whole chapter, the cases that help us in the exams. I will do solve past paper problems, classified past papers, straightforward ones and hard ones. In the next, after we finish this case and the next case, which is two connected particles, polar problems, tension, string problems, be solving past paper problems. This is useful, but this is the most helpful and useful to us as A students, A-level students, to not have problem in the cases in the exams. Last case for today, a force is applied at an angle. A force is acting on the particle at an angle different from the inclined plane. So the inclined plane is this, at angle alpha to the horizontal, and we have force acting on the particle on the plane at angle alpha, at another angle. They might be equal, they might be not equal. But of course, when we introduce a new thing, we consider them not equal. Special case if they are equal. And we have questions in the past paper exams. They are equal, the same frame, the same logic, the same free diagram. So this alpha, as we know before, this is alpha, this is the adjacent one. So this is P cosine theta. So this is the opposite one, P sine theta. We have R, reaction force on the particle. We have the two components. They are perpendicular. Don't forget this fact. Always they do 90 degrees. The mg cosine alpha downwards and mg sine alpha. And the question told us it is up the plane. So the main force is P cosine alpha minus mg sine alpha. We still here in the smooth plane. This case, smooth plane is equal to ma. Look here now, this equation is different, my dear students, from before. Because some students, they depend on memorizing. R always equal mg cosine alpha. It's wrong, it's not. In this case, we have two forces now in the same direction. R, we have the new component of the force P. So R plus P sine theta is equal to mg cosine alpha. According to the diagram, we write the equations of motion. The last part of the last case for today, for now, for this lesson. If the same, we have P force. I wrote it here to you. So we're still in the same case, but part B, let us say, or part 2, on a rough plane. But look at the angle now. It's very important. This will be helping us to understand what did I say in the previous lessons and now, couple of minutes ago. The angle in this case, the force is acting at an angle to the vertical, my dear students. Look, this is the angle. So I wrote this to you here, it will be confuse you, so I will not be writing it. I'll just be saying it. Then you'll be writing it in your language. If you need help with this, please don't be hesitated to communicate on the channel with YouTube. I may focus on it again. I may explain it again. I will answer your questions or I'll do another lesson. We don't mind helping anyone. So we have P here, my dear students. This is P. This is the angle, not the angle to the plane of motion, to the direction of motion. Theta is here, to the vertical on the plane. Yes? So look, this is now the adjacent one. So this one will be P cosine theta. P cosine theta. And this one is sine theta now. Because we have fact, even unfortunately, to be honest to you, some instructors or teachers, they teach mechanics, they are confused in this. They got confused. We don't use horizontal and vertical here. Always horizontal is cosine and always vertical is sine. This is wrong. This is wrong. And this is the evidence. In our case, because of it I erased. I would like to explain it to you now. In this case, this is the particle. And this is the vertical. And the force makes the angle theta. Look, I will do it like outside the shape. So this one now, this one, my dear students, is the cosine. This is the adjacent. And this one, the opposite. So this is the sine. So this is P. And this angle is theta, so this is P cosine theta, and this is P sine theta. This I was writing here, but I wrote it to you in simpler way here. Easy? Yes, this is very important. It's one of the challenging or many students or the majority might be even complain about these problems because you have to focus where is the angle, how the force acts on the particle. This is the most important thing. If you do this right, so you'll be writing the equations of motion right, correctly. So this is P cosine theta. This is P sine theta. And the particle is moving up the plane. So P sine theta in this case is the main force. Minus mg sine alpha plus Fr, because the plane is rough, is equal to ma. There is difference here between these two cases. Look here, R was P sine theta, here R plus P cosine theta, according to the angle. This angle, focus again, it's adjacent or in the direction of motion. This one is to the vertical. Yes, look, makes 90 theta with the vertical. Acts at angle theta to the vertical. So this is the cosine in this case, and this is the sine. So R plus P cosine theta in this case is equal to mg cosine alpha, which is the adjacent component of the weight, plus the certain equation. It always exists when you have friction. Friction is equal to mu R. I wrote to you here to not forget. Notice here in this example that the component parallel to the plane is sine. Parallel to the plane is sine in this case. And perpendicular to the plane is cosine. The angle is cosine. I'll be solving problems in the next video on this before we move to the case of connected particles, to make sure that we understand and we do problems with numbers, with calculator, and we solve problems to enable us to understand and to be prepared more for M1 exams. Read these notes and listen well how we introduce these cases to be prepared for the next. I wish I did introduce it in simple and easy way and non-confusing at all. I wish you all the best. Thank you so much.